Hello, good morning everybody. My name is Vishvadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. In today's lecture, we are going to solve the questions which are most expected questions of COA. I thought I will have the questions of COA and data structure, but this time I have brought for you only questions of COA just because I was able to make more than 20 expected questions for you guys for this particular session. So this particular session will be having only questions of COA, and after that one more session will be having only for data structure, so that you can learn a lot from those questions and you can solve those questions, so that you can understand what type of questions the gate people can ask in your final exam. Plus, other than that, what kind of question you may expect, so that it will be good for you to solve those questions in the exam very easily. So without any delay, should we start? Okay, let me introduce myself first for those members who don't know me. My name is Vishvadeep, written the gate multiple times, 19, 119, 440, 682. These are my ranks. Masters from IISc, another master from BITS Pilani in data science, 13 years of experience. These are the courses I am taking: COA, data structure and coding interview preparations. You can check out my profile on Unacademy, so that there also you can learn from my classes which I have already taken and which I am taking there. These are the special classes and these special classes are free. So if you are not on Unacademy Plus and you want to learn for free, these special classes you can attend and you can learn from those for free. These all the special classes which I have taken previously are managed, organized on these URLs. So go to this particular link, and there I have managed, organized a specific particular link, a web page. There you will have all my special classes in more organized way. Look at this is the test series we started few days back, few weeks back. This particular test series is absolutely free for you guys, and you can learn from it with the questions of quality. The quality questions are there, and you can learn from this particular test series for free, just free. Yes, but still you are lacking in the problem solving, still you are feeling like your problem solving is not improved, still you feel like your preparation is not up to the mark, then all these problems can be solved here on Unacademy Plus. Go to Unacademy Plus, and there we will help you in the same regards. What are the same regards? We will help you in your preparation, we will help you in your understanding of each and every topic with the ease. We will help you with so many practice questions, so that you can understand each and every topic and its small detail with multiple perspective with very ease. And this particular Unacademy Plus subscription you can take in mode of 24 months, 18 months, 12 months, 6 months, 3 months, 1 month also. And all these subscriptions you can take with discount if you use the code VDEEP10. This particular code is an emotion connect, which will connect your preparation to our hard work. Me and my team will support you in your entire preparation if you use the code VDEEP10 for your Unacademy Plus subscription. So use this code, get the discount, plus connect to this emotion which we brought here on Unacademy for your career. If you want, then Unacademy should provide you a personal coach. That personal coach will give you preparation strategy, will prepare the planning for your studies, will prepare you for you some kind of test analysis, will give you booster sessions, will give you the study materials and practice sets and notes and everything. Then you should go for Iconic subscription. This particular Iconic subscription has all the facilities of Unacademy Plus, plus extra these facilities of having a personal coach. So if you want to go for Iconic subscription, that is also available in the discount if you use the code VDEEP10. This Iconic subscription is available only with 12 months and 24 months facility. So if you guys are fine with all these details, again I am telling you, it's an emotion which we have along with you guys, and that emotion will be connected with you if you use the code VDEEP10 and come for Unacademy Plus. So now we are going to solve the questions, expected questions. These questions are really good in the quality, really interesting to solve some expected questions I have brought for you. Now what you need to bring is energy, excitement, energy and excitement you need to bring so that we can solve the questions. So tell me people, are you ready? Are you ready or not? If you are ready, quickly type down. Let me connect my laptop's charger for you guys so that we will be having uninterrupted learning. Okay, so if you are ready, quickly type down in the comment box so that we can go further. Come on, type down in the comment box. Come on, type down in the comment box you are ready or not, and then we will start the session with the very first question. Ready? No any comment till now, buddy. No any comment till now. मैसेज करो, कहां हो सब लोग, कहां हो भाई, कहां हो. Okay, so very first question, let's start with the easy one. Consider a PC relative mode branch instruction which takes branch on address 760. Which takes branch on 760 means this is the target address. This is the target address given. Target address given 760. Okay, and the instruction has offset value 160. We know that when an instruction is stored in the memory which is of PC relative mode, that particular instruction has an offset which is 160, and this instruction is taking the branch on address, which one? Target address given as 760. Now, what is the address of instruction in the memory if instruction is stored in the memory on 4 location? If you remember PC relative mode, in the PC relative mode we calculate target address by what? Target address we calculate by addition of current program counter value and what? Current program counter value and offset value. So what is the current program counter value? We don't know. What is the offset value? We know 160. So PC you will be getting 600. PC you will be getting 600. But that PC will be incremented value. ये PC जो है incremented value होती है. Yes. So when you will calculate this target address, PC value will be address of the next instruction in the sequence. If PC is this one, then current instructions address will be what? Current instruction is stored on 4 locations. जल्दी से बताओ, अगर 4 locations पे stored है current instruction, then what should be the starting address of the current instruction? That will be current instructions address is equal to what? Address of this instruction is what? 600 minus 4, which is 596. Good. Amazing. Look at this. In the question, it is mentioned that each instruction is stored on 4 locations. Each instruction stored on 4 locations. So if PC is 600, before that whatever the PC was, PC got incremented by 4 क्योंकि एक इंस्ट्रक्शन 4 लोकेशन पे स्टोर्ड है. समझ में आया आप लोगों को? Did you get it or not? I want hello, hi, good morning from everybody. Whoever joined here, how are you, Puri? How are you? How are your preparation going? Everything is good, fine. Had your tea, coffee, morning breakfast or not? Ready for more learning? यार थोड़ी एनर्जी दिखाओ, मजा आएगा, बहुत मजा आएगा. There are really good 20 plus questions I have brought for you, which are like most expected question based on my expectations, based on my experience I have brought for you, and those questions we are going to solve. So if you are ready, that's well and good. Good morning, good afternoon, good night, whichever the greeting you want, you can take. There are so many members who are, awake till entire night, and they were just reading, and they are still watching my lectures. If you are watching my lectures after entire night's study, also very good morning or very good evening, whatever you feel like having. Okay, but what we want is you and me both is your perfect preparation. So if you are ready and you are enthusiastic, you are energetic, and then let's get started. Next, another question number 2. Okay, very good morning, great, amazing. One more thing you can do is please share the link of this particular lecture in all of your groups so that people can join us. People can join us here. Share the link of this particular lecture with maximum number of students so that they can join us and can solve these questions along with us. Look at this. Consider a 6-word instruction which is of following type. So this instruction is of 6 words: opcode, 2 modes, and 2 addresses. The first operand, destination. What is the meaning of destination? The meaning of destination is this particular mode or this particular operand will store the result, of the operation. Fine. First operand uses register indirect mode. Okay, so this particular address will be used for register indirect mode. Okay, and the second operand uses indirect mode. Okay, this particular address will be using indirect mode. Assume each address and operand is of 2 words. So this address is of 2 words. This particular address is also of 2 words, and operands are also of 2 words. Fine. Main memory takes 100 nanoseconds for 1 word access. Fine. अगर main memory को एक word को access करने में 100 nanosecond लगता है, then total memory access time required in this and this and this is what? So if instruction is given of this type, means of course we will have an instruction which requires 2 operands. We have an operation which requires 2 operands. So 2 operands we will take from one from here, and after that we will store the result here. Okay, that's the assumption. That is the assumption that we are going to take 2 operands as source, one from here, and then we will store the result in the destination, which is the first operand. Fine. Let's try to understand how to solve the question. Fetch cycle of instruction. If we are talking about fetch cycle of instruction means only instruction fetch. So very first one, fetch cycle of instruction means instruction fetch. Instruction is of how many words? 6 words. 6 word, and memory access for 1 word takes how much time? 100 nanosecond. So for 6 word, how much time is taken? 6 into 100 nanosecond, which is 600 nanoseconds. 600 nanoseconds only for the instruction fetch. Why? Just because it's a 6-word instruction and 1 word access time is 100 nanosecond. Good, amazing. Next, execution cycle of instruction. Execution cycle of instruction means you need to keep aside fetch cycle. Apart from that, all the remaining phases, including decode, address calculation, operand fetch, and everything. Okay, so if you are calculating the time in execution cycle, then in that you need to take out that for operand fetch how much time is required. For operand fetch only how much time is required. Let's try to understand. To get the operand from here, which is which is which mode? Register indirect mode. What is the register indirect mode? From here we will get a register reference. Fine. From the register we will get a memory address and we will reach to the memory. From here we will get a register operand. Fine. Into the register we will go and there we will find effective address. Using that effective address we will go to the memory, then we will get the operand. So in the register indirect mode, how many times you have accessed the memory? One time. And what you are accessing from the memory? Operand. What is the size of operand? 2 words. To access one operand of 2 words, how much time is required? 100 nanoseconds for 1 word. For 2 words, how much time? How much time? 2 into 100 nanoseconds. That is for the first operand. Plus second operand. Second operand is using what? Second operand uses indirect mode. Second operand uses indirect mode. Indirect mode means how many cycle? Indirect mode means how many times you need to access the memory? 2 times. 2 times. Indirect mode says here we will be having some address. Let's take that address. Go to the memory. You will not get the operand, but you will get effective address. And use that effective address. Again access the memory and you will get operand. 2 times access? Yes. One time you are getting the address. Another time you are getting the operand and both are of 2 words. So 2 words plus 2 words, 4 words you are accessing from the memory and 1 word access is 100 nanosecond. So this time you will require 4 access of 100 nanoseconds each. For operand fetch only, you will require 400 plus 200, 600 nanoseconds. Are you convinced with this? Are you okay? Are you convinced with this? क्लियर है कि नहीं है? आगे बढ़ पाए? आगे बढ़ेंगे या नहीं? This is only operand fetch. This is only operand fetch. Now write back. Now write back. Once operation is performed, for the write back, how much time is required? For write back, how much time is required? What is the destination? What is the destination? Destination is first operand. First operand is destination. First operand is destination means this one. It is using register indirect mode, and we have seen for register indirect mode only 2 memory accesses are required. Means 2 word access, 1 time access required. 1 memory access, 2 words access. 2 words access means 200. 2 into 100 nanoseconds required for write back. So total for second question for execution cycle, total time required is how much? For execution cycle, total time required is equal to 600 plus 200, 800 nanoseconds. Yes or no? Clear है सब लोगों को? Is that clear? Is that clear? Is that clear? Is that clear? Clear है कि नहीं है? नहीं है, नहीं है कि है? अभी लास्ट क्वेश्चन क्या है? थर्ड इंस्ट्रक्शन साइकिल. इंस्ट्रक्शन साइकिल मीन्स इंक्लूडिंग द फेच साइकिल एंड एग्जीक्यूशन साइकिल कंप्लीट, स्टार्टिंग फ्रॉम द फेच to the execution everything, starting from the fetch to the execution everything, which means the third question we will have is fetch plus execution cycle both, total how much? 1400 nanoseconds. 1400 nanoseconds will be required to execute this complete instruction. Is that clear? Is that clear? Yes or no? Is that clear? 1400 nanoseconds per instruction. For this particular instruction, for such kind of instruction, 1400 nanoseconds are required to be executed. Fine or not? Clear है सब लोगों को? Clear है सब लोगों को या नहीं? Okay? Fine. Now look at this. Look at this. What is asked? What is asked in the question? कि total memory access time required in the fetch cycle. So how exactly you will approach such questions? You will approach such questions like reverse way. What is asked? Fetch cycle of instruction. Fetch cycle of instruction means instruction fetch. In instruction fetch, what I do, sir? I do fetch the copy the instruction from memory to CPU's instruction register. This is the instruction fetch. So in the fetch cycle, how much time is required? Time required is equal to time required to bring the instruction from memory to CPU. Now whatever the information given, based on that I could understand this instruction size is 6 words, so I'll have to copy 6 word instruction from memory to CPU. Now 6 word instruction is there, then 6 word instruction will take how much time to bring it from memory to CPU? They have given 1 word memory access 100 nanosecond, 6 word 600 nanosecond. So always approach the question in the reverse way कि what is asked, based on that go into the bottom to top approach and map it to your given question. So it's not that from the given material, from the given data, how you are going to reach to the solution. No, it's the wrong approach, just because from given data you can get thousands of things. You can get thousands of things. Yes. But I don't want to go for thousands of things. I want to go for only one thing. So that particular approach will be wrong. Reverse one is better. You think like that way. If this is asked, how we will approach to go for this one. I will solve few more questions. You will understand how exactly we can approach. Another question, question number 3. Consider a system which supports 2 address, 1 address and 0 address instructions. 3 types of instructions supported. Okay, remember, if any person who have solved my classes, who have attended my classes, as soon as that fellow will read this first line, that fellow will draw the format of all these 3 types of instruction format. Format of all these 3, definitely immediately that fellow will draw. That is my first statement I always told to my students multiple times. Then as soon as whenever instruction is given, draw its format as soon as possible. I have drawn the format of each and every instruction as soon as possible. Now further you read the question, you will understand the given information slowly and map it to your problem. Okay, so this is the given thing. 3 types of instructions are given. This is 2 address instruction, this is 1 address instruction, and last one is 0 address instruction. And what is the format? You all are aware of the formats. आपको सबको format पता है, सबको format पता है. क्या होता है format? Look at this. Opcode and 2 addresses. Address 1, address 2. Similarly, 1 address instruction, opcode, address 1, that's it. And 0 address instruction does contain only opcode. That is the format. As soon as I read the first statement, I have drawn the formats. Now, it has 32-bit instructions and 13-bit addresses. Okay, 32-bit instructions. Complete 32-bit instruction everywhere. 13-bit addresses. So 2 addresses of 13 each, 1 address of 13 each. Here is no any address. Fine. Now if 13-bit addresses, then how many bits for opcode? How many bits for opcode here? 13 into 13, 26. 32 minus 26 is 6. Remaining here 19 bits. And here all 32 bits are for opcode. So opcode bits I have calculated based on it. Now, if there are 16,376 1 address instructions and 655,360 address instructions, then maximum how many two address instructions can be formulated. So two address instructions are asked. I don't know what is two address instruction is, how many two address instructions are possible, but if you have solved such kind of questions along with me, you need to understand this. I have told you how to solve such questions. I have told you how to start such questions. Start solving the question with that format which is having, किस इंस्ट्रक्शन फॉर्मेट के साथ स्टार्ट करेंगे, हम उस इंस्ट्रक्शन फॉर्मेट के साथ स्टार्ट करेंगे जिसमें होती है मिनिमम ऑपकोड बिट्स. वी विल स्टार्ट विद दोज क्वेश्चंस विद दोज इंस्ट्रक्शन फॉर्मेट विच इज हैविंग मिनिमम ऑपकोड बिट्स. किसमें है मिनिमम ऑपकोड बिट्स? विच इज हैविंग मिनिमम ऑपकोड बिट्स? टू एड्रेस इंस्ट्रक्शन. सो स्टार्ट विद दैट. Somehow you need to start with that only. So based on opcode, how many maximum opcode combination you can have using 6 bits, maximum how many opcodes you can generate, which is 2 power 6, 64. Do I have the number that how many two address instructions are possible? I don't have. It is fine, no problem. Let's take it as n. लेट्स टेक इट एज एक्स और एन. एक्स ले लेते हैं, ये आप बचपन से कर रहे हो कि कुछ नहीं पता है तो एक्स ले लो, ठीक है. लाइक योर फ्यूचर वाइफ और फ्यूचर स्पाउस, राइट? यू डोंट नो अबाउट हिम और हर. लेट्स टेक इट एज एक्स. ओके, नाउ सी मैक्स ऑपकोड 64. ओके, अगर मैक्स ऑपकोड 64 है, हाउ मेनी यूज्ड ऑपकोड वी कैन हैव? यूज्ड ऑपकोड इज एक्स. I don't know right now how many two address instructions are possible. Let's take it as x. How many unused combinations are there? How many unused combinations are there? 64 minus x. These unused combinations I will be using to get the number of one address instructions. Fine. How many one address instructions we can formulate? So let's first do one thing. Divide this 19 bits into two parts. This type of questions are very specific. आपको सीखना पड़ेंगे कैसे सॉल्व करना है, and this in my all the lectures I have beautifully explained. Go to check my 52 lecture playlist. In that multiple instruction support I have solved 2 or maybe at least one session completely only for such kind of questions. Go and check it out. आपको सबको मिलेगा, सबको मिलेगा, सबको समझ में भी आएगा. Look at this. Look at this. So 19 bits you need to divide into two parts. First part should have exactly same bits as the previous level opcode 6 and remaining 13 as it is. From these 6 bits, how many unused combinations we are getting from previous level? 64 minus x into 2 power 13. All the combination of remaining 13 bits. These are the maximum. These are the maximum one address instructions. These are the maximum one address instructions, and among those available maximum one address instructions, we have used 16,376. We have used 16,376. So if used are 16,376, then how many unused you will be getting from here? How many unused combination we will be getting from here is 64 minus x into 2 power 13 minus 16,376. These are the unused combination from one address instruction, and these you guys are using or going to use to get the zero address instructions. Fine, let's go for zero address instruction formulation. Divide करो इसको भी दो पार्ट में. कैसे डिवाइड करेंगे? कैसे डिवाइड करेंगे? डिवाइड दो two parts like that way कि first part should have exactly same number of bits in the previous level opcode, which is 19, and remaining 13 bits here. Using these 19 bits, how many unused combinations we are getting from the previous level, which is 64 minus x into 2 power 13 minus 16,374, sorry, 76. These are the unused combination, and into 2 power 13. These are the maximum opcode combinations for zero address instruction, and this is equal to 65536. This is equal to 65536. Okay, so let me write on the next page. It is 64 minus x into 2 power 13 minus 16,376 into 2 power 13, which is equal to 65536. इतने zero address instructions हैं. Let's solve this particular equation and we can get the value of x. Can you solve the equation for me? This is 2 power 16. 2 power 16 divide by 2 power 13, you get 8. 2 power 3. 2 power 16, this is. Divide by 2 power 13, you will get 2 power 3, which is 8. So it is like 64 minus x into 2 power 13 minus 16,376 is equal to 8. Now this, you get that side, you will be getting 64 minus x into 2 power 13 is equal to 76 plus 8, you will be getting 16384. 16384 is how much? 16384 you will be having is equal to 2 power 14. So this becomes 64 minus x is equal to 2 power 14 divided by 2 power 13, which is 2. So x value you will be getting as 64 minus 2, 62. Is just a simple कैलकुलेशन. इट्स जस्ट अ सिंपल कैलकुलेशन. आप सिंपल कैलकुलेशन करेंगे और आपको आंसर मिल जाएगा. ये बहुत टफ क्वेश्चन था, बहुत टफ क्वेश्चन था. इफ यू नो हाउ टू सॉल्व सच क्वेश्चंस देन ओनली यू विल बी एबल टू सॉल्व दिस स्पेसिफिक क्वेश्चन. एंड one more thing which is more important, which is more important, which is more important, which is more important. one thing is कि आपको ऐसे क्वेश्चन सॉल्व करना आना चाहिए. यू नीड टू लर्न हाउ टू सॉल्व सच क्वेश्चन. देयर इज अ क्वेरी कि सर जीरो एड्रेस मैक्स ही यूज करेंगे. जी हाँ, जो गिवन है उसी को यूज करेंगे. जो गिवन है जीरो एड्रेस इंस्ट्रक्शन इतना है तो हम उतना यूज कर लेंगे, उसके इक्वल रख के और सॉल्व कर लेंगे. किसी ने लिखा गेट में नहीं आएगा ये. अरे सर, आप अगर प्रिडिक्ट कर लेते कि गेट में आएगा या नहीं आएगा तो फिर आईआईटी वालों की जरूरत ही क्या रहती. आप ही टेस्ट पेपर सेट कर लेते. There was a straightforward question in GATE 2 years ago in 2018 which was having 4 types of different types instruction. It was a direct instruction or direct question from one level to last level. But if the reverse is asked like that way, then definitely you should know. Just because last year they have given such kind of question for just 2 types of instruction for supported. Last year, yes, last year only, 2020 only, they have given a question based on the same concept which were involving only 2. If you remember, a question is there, R type and I type instruction. So I have made that question into even in more difficult levels so that you should be prepared for such kind of questions if that will be asked in the exam. आपको समझना पड़ेगा वो. चलिए, क्वेश्चन नंबर 4, नेक्स्ट वन. A digital computer has a memory unit 32 bits per word. Fine. So we have a memory unit in which 32 bits are there on each word. The instruction set consists of 240 different operations. Instruction set consists 240 distinct operations means 240 instructions are supported by your computer system. 240 instructions supported by computer system. Now. Next. All the instructions have an opcode part, operation part, and an address part. Only one address. So what is the format of instruction given? Format of instruction is this. Format of instruction is this. Every instruction contains one opcode and one address. Now, next. each instruction is stored in one word of memory. One word of memory means 32 bits. So instruction size is 32 bits. Fine, fine. Now, based on given information, if number of instructions are 250, if number of instructions given in the question itself, okay, let me write down here, number of instructions are 240. Can you tell me for opcode how many bits are required? Number of instructions is equal to 240. How many opcode bits required from here? For 240 instruction support, opcode bits required is equal to how many? जल्दी से बताओ. I want your answer. ये टीचर आंसर मांगता है. Opcode is equal to log of 240 which is 9 bits. कि 8 bits 8 bit में काम हो जाएगा. Yes, 256, 2 power 8 is 256. Yes, we will get the 8 bit opcode. 8 bits opcode. 8. So opcode is 8 bits. Remaining address part, 32 minus 8 is how much? 32 minus 8 is equal to 24 bits. Now, what is the question? Question number 1. How many bits are needed for opcode? 8 bits. Question number 1 solved. Question number 2. How many bits are left for address part of instruction? 24 bits. And question number 3. What is the maximum allowable size of memory? We can feel it like this way. If 24-bit address we can have 24-bit address means 2 power 24 different locations, and for each location, on each location we can store one word of 32 bits. This is the maximum allowable size of memory. You can convert this into kilobits, megabits or megabyte or whatever. Let's convert this into megabyte. This becomes 4 bytes. 2 power 26 bytes it becomes, which is 64 megabytes. Maximum allowable size of the memory is 64 megabytes. So 2 power 24 number of addresses. On each address we can store one word. In that case, maximum allowable size is 64 megabytes. Got it? Now this particular expected question is actually covering 3 questions. Number 1, 2, 3. 3 questions. They may ask any of these 3 questions as one particular question, and in one question only I have covered 3 different questions. It is easy. Remember, it is easy, but you will be able to solve such questions. आपको ये question solve करना आना चाहिए. And when you write the GATE exam, that's the biggest problem you face, कि when you solve, you don't get confidence कि ये सही है कि गलत है. This particular question is correct or not, I am getting correct answer or not, that will be a big problem for you. And that particular problem will be solved once you will solve so many questions by yourself, and then after solving the question you get to know कि yes, it is correct or not. So practice. After that you just check that your answer is correct or not, and if you get maximum number of such kind of questions answer correct, then only you will be getting some good confidence. Another question number 5, very simple, very simple. It's a theoretical question. Look at this. Read the question, check it out, and let me know if it is solvable for you. Disadvantages of using 2 address instructions in place of 1 address instructions are: if we are using 2 address instruction instead of 1 address instruction, then what will be the disadvantage? More memory required for the program? No. As compared to 1 address instruction, 2 address instructions will not require more memory. 1 address instructions will require more memory just because so many instructions will be required for the program. So this is wrong. No, it's not a disadvantage as compared to 1 address instruction. Next, larger size instructions. Yes, that is true. Instruction size will be little larger. More number of instructions? No. More number of instructions will be there in 1 address instruction. So only 2, option C is correct. We are talking about disadvantages of 2 address instruction as compared to 1 address instruction. if we will compare two address instructions is in place of three address instruction, then in that particular case first and third will be true. First and third will be true in that case. ओके गॉट इट. आगे बढ़ते हैं. क्वेश्चन नंबर 6. यू नीड टू अंडरस्टैंड कि व्हाट यू आर कंपेयरिंग विद व्हाट एंड बेस्ड ऑन दैट यू नीड टू फॉर्म द आंसर. अदरवाइज आपका क्वेश्चन का आंसर गलत हो जाएगा और आप पीछे आ जाएंगे. यस, in last quiz which I conducted on Unacademy Plus, one student told me कि sir only 40 members, around 35 to 40 members written the test on the time, and just because of 0.33 marks my rank got reduced by 8 members. Yes, 8 रैंक पीछे हो गया 40 में से. 1/5 position gone down just because of 0.33 marks. So you understand, if you will get less marks, 0.33 less than others, then your rank will reduce in hundreds. Yes, in hundreds. Means in just one wrong answer you will lose IIT ka I to NIT ka N. Yes, might possible. So you need to be very precise, very correct, and very confident for each and every question to be corrected. Okay, next question number 6. Advantage of using 4 address instructions in place of 3 address instructions is. Advantage of 4 address. Less memory required for the program? No, not at all. It requires more memory. Smaller size instruction? Not at all. Less number of instruction? No any advantage we have of 4 address instructions in place of 3 address instruction. It's D, none. Number of instructions for 3 address and 4 address will be same to same. 4 address instructions will extra have thing what the address of the next instruction included within the instruction itself. Why? Just because we don't use PC over there. That's the only difference. And because of that, size of instruction becomes larger. Yes, less memory is required for the program. No. And less number of instructions. No. These all not any advantages of 4 address instruction. If somebody says what are the qualities or which is true among these 3 about 4 address instruction, then might possible few of the statements are correct. कुछ जो हैं, कुछ इनमें से जो हैं वो हो सकता है 4 एड्रेस इंस्ट्रक्शन के लिए ट्रू स्टेटमेंट है. लाइक लेस नंबर ऑफ इंस्ट्रक्शन, स्मॉलर साइज इंस्ट्रक्शन, लेस मेमोरी रिक्वायर्ड, कुछ भी सही नहीं है इनमें से. नथिंग इज ट्रू फॉर 4 एड्रेस इंस्ट्रक्शन, बट माइट पॉसिबल सम स्टेटमेंट कैन बी करेक्ट फॉर 4 एड्रेस इंस्ट्रक्शन, बट दोज आर नॉट एडवांटेजेस. तो आपको ये चीज सोचना पड़ेगी कि व्हाट दे आर आस्किंग फॉर advantages. They are not asking for which statement is true or false. समझ रहे हो? ये चीज ध्यान रखना जरूरी है. Okay, got it. Next question, very simple again. A computer system contains a cache. Fine, बहुत अच्छी बात है. Congratulations system. Uncached memory system takes uncached. Uncached का मतलब क्या होता है? Uncached memory means that memory system which does not include cache memory. If the memory system does not include cache memory, means it has only main memory. So uncached का मतलब क्या हो गया? Uncached means only main memory system. So uncached memory access takes 7 times longer than access to cache. तो अगर कैश मेमोरी का एक्सेस टाइम TCM इज इक्वल टू x टाइम यूनिट है, तो अनकैश्ड मेमोरी सिस्टम मींस मेन मेमोरी एक्सेस टाइम शुड बी 7x. सिंपल स्टेटमेंट. If cache has a hit ratio 0.9, so hit ratio of cache memory is given 0.9, then the ratio of cache memory access to uncached memory access time is cached memory मतलब क्या होता है? If uncached means the memory system which does not include cache, then the cached memory system means what? Cached memory system means the memory system which include cache. कैश्ड का मतलब है एक ऐसा मेमोरी सिस्टम जिसमें कैश मेमोरी इंक्लूड है. अगर कैश मेमोरी इंक्लूड है तो क्या मेन मेमोरी हटा दोगे? Will you remove main memory if you will include cache memory? No, sir. So it's very simple. Cached memory system means a memory system in which you have cache memory and main memory both. Got it? Got it? Got it? Now listen. Listen. How do you calculate a memory access time when you have cache? When you have cache means cached memory ka access time means what? The memory access time when you have cache memory and main memory both means nothing but T average. Average memory access time when you include cache memory and main memory both. In that case, the ratio which they have asked in the question is cached access time, which is nothing but T average divided by uncached memory access time is main memory. Now, based on the question, we are going to use hierarchical access or simultaneous access for T average. Simultaneous access. क्यों? क्योंकि just because we have not used in this question no any word kind of hierarchy or level is used. Word hierarchy या level use नहीं हुआ है इसलिए. So T average will be what? When there is a hit. When there is a hit, कैश का एक्सेस टाइम प्लस व्हेन देयर इज अ मिस मेन मेमोरी एक्सेस टाइम 7x डिवाइडेड बाय TMM which is 7x. When you will calculate this, it becomes 0.7 plus 0.9. 1.7x divided by 7x means 1.6 divided by 7 comes as 0.22 and something. So we got the answer also from one of the fella, which is correct one. So it's a really good one. Nice, amazing, 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 nice, amazing. So you need to understand what is asked. Again, let's try to understand how you are going to approach this question. A computer system contains a cache. Fine. Uncached memory system takes 7 times longer than access to cache. If you understand uncached means no any cache involved, means only main memory. Fine. So based on that, I have written this equation. If cache has a hit ratio 0.9, fine. The cached access time to uncached access time ratio is, so first I will start from here. They have asked cached access time. Cached access time means cache memory main memory ka combined access time, T average, divide by uncached memory access time means TMM. I will calculate this, I will calculate this, I will get the correct answer. Everybody clear about this? Can we go further? If everybody is clear about this, can we go further? So we are still left with so many questions. Some minimum 15 questions are still left. So we are having so many such questions. If you are fine with this, can we go for the next one? Let's solve this one. बहुत easy question है, बहुत easy. What hit rate is required for cache to reduce the effective memory access time from 200 to 47 nanosecond if cache access time is 20 nanosecond? Okay, so first of all I can understand one last thing is cache memory ka access time is 20 nanosecond. Fine. They are asking that with using the cache memory, we are reducing the effective memory access time from 200 to 47. Means I can feel it like that way. I can understand it like that way. Ki if we are not having any cache, without cache, I was having memory ka access time 200 nanoseconds, right? but using the cache of some hit rate and 20 nanosecond time, with cache I am able to get memory access time of just 47 nanosecond. Now it's very simple question. Now this particular question turned into without cache मतलब कौन सा main memory है आपके पास या कौन सा memory system है आपके पास. Without cache means which memory system you have for you. Without cache means you have only main memory. Without cache means you have only main memory, means this is TMM given. Main memory access time given 200, and with cache means it's an average memory access time given. So average access time 47 nanosecond, main memory access time 200 nanosecond, cache access time 20 nanosecond. Regular formula you use for T average and get the hit rate. So based on the given question, we are going to use simultaneous access. In the simultaneous access, what is the formula for T average? So for T average, we are going to use the formula T average is equal to, when there is a hit, time required is cache memory ka access time, plus when there is a miss, time required is main memory ka access time. Calculate the value of h from here. I want the answer from your end. अब मुझे answer आपकी तरफ से चाहिए. I want answer from your end. If you will solve the question from your end, you will be getting h is equal to 85% or 0.85. 85% hit rate you will get from here. Clear? Everybody, are you clear about this? Yes or no? Let me know so that we can go further and we can solve the questions now. Let's see further. There are so many questions. Exactly. Yes, correct, perfect. Amazing. Question number 9, another question. Consider a memory with average size of x bits or maximum size of x bytes. So the size of memory is given x bytes. Memory is word addressable with word size of w bytes. So memory is of this size, but this is not byte addressable memory. It is a word addressable memory and word size is w bytes. The size of address bus of processor is at least how many bits? So first of all, if these many bytes are there in the memory and one word size is this much, then we need to calculate how many number of words are there in the memory. We need to calculate number of words in the memory. Kitna number of words aayega in the memory? Number of words will be w divided by x or x divided by w. X divided by w. X divided by w. Number of words will be x divided by w. For these number of words, what will be the address size? What will be the address size for these number of words? Take the log. Take the log base 2. Take the log base 2 of this x divided by w. That will be the address size in the bits. Answer is option A. Can you tell me for the same question for byte addressable memory, what will be the address size? For byte addressable memory, what will be the address size? For the same question. For the same question for byte addressable memory, what will be the answer? If the memory will be byte addressable, what will be the answer? Answer will be address size of this particular memory will be log of number of bytes, which is capital X. These many number of bits will be there in the address. Got it? Yes or no? Yes or no? Yes or no? Okay, I'll tell you one thing. I will take some example. Let's say x is equal to 32 bytes. We have 32 byte memory overall, but these 32 bytes, each and every byte doesn't have an address. Let's say you have word size is equal to 2 bytes. So for every 2 byte we have one address in the memory. For every 2 byte we have one address in the memory. Total how many addresses are there in the memory? Total how many addresses are there in the memory? 32 divided by 2, 16 addresses will be there in the memory. 16 total number of addresses. 16 total number of addresses. This particular address will be requiring how many bits in the binary? If I want to give 16 addresses in the binary, how many bits are required? How many bits are required? 4 bits address will be required, which is nothing but log of 16, and 16 is log, or 16 is nothing but x divided by w. So log of x divided by w, option A is correct for the word addressable memory. And for byte addressable memory, we have 1 byte, 1 address. That's why log of 32 will work. समझा आप लोगों को? समझ में आ रहा है क्या बात कर रहे हैं हम? What I am talking about, are you able to understand, people? Are you able to understand or not? Can you tell me, are you able to understand or not? बोलो रे भाई, बोलो रे बाबा, बोलो. Understanding. See, the most important part of your learning should be, you should feel the topics. फील जरूरी है बॉस. जैसे जाकिर खान एक कॉमेडियन है, उनके लिए बोलते हैं कि बादल जरूरी है, वैसे ही आप और हमारे लिए यहाँ लर्निंग के लिए फील जरूरी है. इफ यू विल फील द लर्निंग, यू विल डेफिनेटली लर्न अ लॉट फ्रॉम दीज सेशंस. आपको बहुत कुछ सीखने को मिलेगा, बहुत कुछ सीखने को मिलेगा. Okay, so let's go for the next question. Question number 10. Consider a memory hierarchy with a write back cache. Okay, write back cache. As soon as I read this word, write back cache means only updation happens in the cache memory whenever updation is there in the memory. When a block is replaced from cache memory, then only we are bringing it to the main memory. That is the write back cache. Write through, write back wala, right? The cache had an access time of 25 nanoseconds. So given thing is cache memory access time, TC, is 25 nanoseconds. Comma, 90% of all memory accesses are found in cache itself. Means 90% time we have found the content of CPU into the cache memory. So can I say there is a hit in cache memory 90% time? The main memory access time is 300 nanoseconds. Okay, TMM is 300 nanoseconds. The 20% of cache blocks are dirty. So dirty blocks percentage X is equal to 20%. The cache block size is 4 bytes. Block size is of 4 bytes. Calculate the average memory access time. So if you know what is the average memory access time in the case of write back, well and good. If you don't know, let me tell you. It's a memory hierarchy, hierarchical system. Yes. So first of all, when there is a hit, first of all, only cache memory access time is required. Plus, when there is a miss, then first of all, cache memory access time is required to check it's a hit or miss. Plus, a block access time is required from main memory. Plus, some extra write back time is required. Just because it's a write back cache, this much time required. So, okay, a person says जो नहीं पढ़ा वो आ रहे हैं क्वेश्चंस. थोड़ी सी देर रुक जाएं, कुछ 2-3 क्वेश्चंस हमारे कैश मेमोरी के हैं, कुछ क्वेश्चंस आने वाले हैं जो अभी आयो के भी हैं, पाइपलाइन के भी हैं, डीएमए के भी हैं, सारे टाइप के क्वेश्चंस मिलेंगे. आप कुछ क्वेश्चन जो आपने नहीं पढ़े हैं कोई प्रॉब्लम नहीं, थोड़ी देर रुक जाएं, आपको कुछ ना कुछ तो अलग सीखने को मिलेगा ही मिलेगा। फिर वो क्वेश्चन भी आएंगे जो आपने पढ़े हैं तो वो भी आपसे बनेंगे। लुक एट दिस। अब देखते हैं कि ब्लॉक एक्सेस टाइम कितना है। ठीक है, लेट्स सी हाउ मच इज ब्लॉक एक्सेस टाइम। टी ब्लॉक एक्सेस टाइम, मेन मेमोरी से ब्लॉक का एक्सेस टाइम कितना होगा। टी ब्लॉक विल बी इक्वल टू, in one main memory access you can access only one byte। यूजुअली मेन मेमोरी के एक्सेस से एक बाइट आप एक्सेस कर सकते हो एक बार में, और यहां पे ब्लॉक का साइज कितना है 4 बाइट। द ब्लॉक साइज इज 4 बाइट्स हियर, सो यू विल रिक्वायर 4 टाइम्स मेन मेमोरी का एक्सेस ऑफ 300 नैनोसेकेंड्स। आंसर विल बी 1200 नैनोसेकेंड्स। 1200 नैनोसेकेंड्स विल बी ब्लॉक एक्सेस। अब बात करते हैं राइट बैक का टाइम कितना लगेगा। टी राइट बैक विल बी हाउ मच। T write back will be dependent on how many percentage of the blocks to be written back. Now look at this, only 20% of the blocks are dirty, means only 20% time I will need the write back, and that particular 20% is this 0.2 times you will require the write back time, and which is nothing but block access time from main memory। कितना लगेगा, कितना लगेगा 240 नैनोसेकेंड्स। 240 नैनोसेकेंड इज द राइट बैक टाइम ऑन एन एवरेज, राइट। ओके, 20% टाइम you will require the block access time, that's why 240 nanosecond is the write back। Let's place these values here, let's place these values here। So hit ratio given, which is 90%, 0.9 times you will require only 25 nanoseconds, plus 0.1 times you will require first 25 nanoseconds for cache memory access time, plus block access 1200 access time, plus write back time is 240। Can you calculate this completely? I want the answer from your end। Can you calculate this now? Can you calculate this now? Very good morning everybody, very good morning। जिन्होंने लेट से ज्वाइन किया है कोई प्रॉब्लम नहीं है, हर एक क्वेश्चन अलग है, एवरी क्वेश्चन इज न्यू। लाइक द सेशन एंड एंजॉय द क्वेश्चन सॉल्विंग हियर। मजा आएगा, बहुत 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 मजा आएगा। जल्दी से सॉल्व करके बताओ क्या आंसर आ रहा है, जल्दी से सॉल्व करके बताओ क्या आंसर आ रहा है। व्हाट इज द आंसर? क्विक क्विक क्विक। quickly। So it will be 25 plus 1200 plus 240 into 0.1 plus 25 into 0.9. I am getting 169। I am getting 169। Are you getting the same thing or different? 1400 कुछ ज्यादा नहीं आ गया? It's too much। 1400, no, you will not get 1400। That 1400 is too much। 1400 is too much। You should get answer lesser than 300 nanosecond। अगर आप 300 nanosecond से ज्यादा लेके आ रहे हो, means using the cache memory you are getting more access time than the memory access time itself। That's a wrong approach। आप cache memory use करके भी main memory से ज्यादा access time लेके आ रहे हो, तो cache का use करने का फायदा क्या है? 169 I am getting, that is the correct answer। अरे यार कैलकुलेशन मिस्टेक तो ना करो यार, कैलकुलेशन मिस्टेक तो ना करो, कैलकुलेटर ही तो चलाना है। Okay। Let's go for the next question। Yes, got it। 170 169 almost you are getting। Okay, next question। Here is question number 11 for you। A 64 bits wide main memory unit with a capacity of 4 GB is built using this 256M cross 16 bits RAM chips। How many chips are required to construct such memory, and how the chips are arranged? First of all, we need to understand what is the meaning of 64 bits wide। 64 bits wide means CPU expects that on each address 64 bits should be stored। The expectation of CPU is what? whenever CPU generates an address, CPU needs 64 bits value. CPU needs 64-bit content on each address. So if one data size is 64 bits, which is nothing but how many bytes? 64 bits means 8 bytes. 8 bytes, yes or no? So this particular overall memory of 4 GB should be organized in such a way some number of words cross each word size is 8 bits. Sorry, 8 bytes. Each word size is 8 bytes. Okay, got it. Okay, there is a question that there is no any role of dirty blocks. Look at this. Role was there of dirty blocks. Write back, T write back I have calculated based on dirty blocks. 20% dirty blocks. Based on that only I got 240 and that I have added here. Write back के लिए dirty block include किया था. Dirty block include किया था. Okay, now come back here. What I told, 64 bits wide main memory means on each address CPU expects 64 bits 8 byte ka data, but we have total capacity of 4 GB. So 4 GB capacity of memory should be organized in such a way some number of words cross each word will be of 8 bytes. So can we calculate from here number of words in main memory? Number of words in the memory will be equal to 4 GB divided by word size 8 byte. And this becomes 4G is 2 power 32, 8 is 2 power 3. So this becomes 2 power 32 divided by 2 power 3, which is 2 power 29. So the memory we can write as 2 power 29 number of words are there and each word size is 8 bytes. Like this way you can have this memory system. Now this memory system I need to build using this type of chips. So how many number of chips are required? It's very simple thing. Number of chips required is equal to total capacity of memory 2 power 29 cross 8 bytes divided by one chip capacity 256M cross 16 bits. Let's make the formats compatible. So if it is 2 power 29 cross 8 bytes, I will convert this one chip capacity also into same format. 256 is 2 power 8. M is 2 power 20. So this becomes 2 power 28 cross 16 bits means 2 bytes. Right? So now address separately you divide. This you will get from here is number of chips 2 power 29 divided by 2 power 28, which is 2 power 1. So 2 cross 8 divided by 2 is 4. Number of chips are 8. Number of chips are 8. If number of chips are 8, how these are organized? Number of chips are this, organization like this way. Organized the chips like this way, you will be having each horizontal arrangement with 4 chips and such kind of 2 horizontal arrangements you need, or like this way in vertically 2 horizontal arrangements are arranged like this way. So this will be the organization of chips 2 cross 4. In one horizontal arrangement you will be having 2 chips, such kind of in the vertical manner 2 horizontal arrangements will be there. Clear? Total 8 chips, and you will be having such kind of arrangement. Got it. क्रैश कोर्स में नहीं पढ़ाया, क्रैश कोर्स में बिल्कुल पढ़ाया है, इस टाइप का क्वेश्चन भी सॉल्व किया है। आप देखिएगा जरा, मल्टीपल चिप्स कैश में रैम रोम चिप्स में मैंने ये बात की है, आपको बिल्कुल की है। क्वेश्चन सॉल्व नहीं कराया होगा, हो सकता है जस्ट बिकॉज क्रैश कोर्स में हम बहुत क्विकली जा रहे थे, बट डेफिनेटली पढ़ाया है। आप लॉन्गर जो मेरा सेशन है वहां देख सकते हैं, वहां भी मैंने ये चीज को बहुत ब्यूटीफुली एक्सप्लेन किया है यार, जाके आप देखें, पूरे लेक्चर्स हैं, सब कुछ एवरीथिंग आई हैव एक्सप्लेन्ड विद मोर एंड मोर रिक्वायर्ड डिटेल। जितनी डिटेल रिक्वायर्ड है आपको, ये अरेंजमेंट कैसे होगा, क्यों होगा, किस तरीके से होगा, डिकोडर कितना लगेगा, किस किस को इनेबल करेगा, किसको नहीं करेगा, सब कुछ बताया है, सब कुछ। एवरीथिंग आई हैव टोल्ड इन द क्लासरूम, चाहे वो मेरी प्लस की हो या चाहे मेरी वो यूट्यूब की हो। ओनली thing different on Unacademy Plus is we solve so many questions over there कि you will have a good practice, hands-on practice on each and every topic. Next, another question. This is one of the really good question. It involves so many questions, 1 2 3 4 5 5 क्वेश्चंस मैंने यहाँ लिखे हुए हैं, और ये पांचों क्वेश्चन के आंसर 5 अलग अलग क्वेश्चन, मे बी मल्टीपल सच क्वेश्चंस कैन बी आस्क्ड बेस्ड ऑन द गिवन डेटा। बहुत सारे अलग अलग टाइप के क्वेश्चंस बन सकते हैं यहाँ से। सो आई हैव ब्रॉट ऑल दोस क्वेश्चंस टुगेदर इन द सिंगल क्वेश्चन। लेट्स रीड, you read, try to understand, then after that I will start explaining the question to you. Consider a non-pipelined processor with a clock rate of 5 gigahertz and an average cycles of 4 per instruction. Non-pipeline system, rate is given, CPI is given. CPI means number of cycles per instruction. The same processor is upgraded to a pipelined processor with 6 stages and clock speed of this. Assume that there are no stall cycles. Okay, so first of all, for non-pipeline system, if the clock rate is given, can you calculate the cycle time? Can you calculate cycle time for non-pipeline system? Yes, we can calculate non-pipeline time or non-pipeline cycle time. Yes, which is 1 divided by clock rate, which is gigahertz. Okay, fine. 1 divided by 5 gigahertz, which in turns to 0.2 nanoseconds. ये कैसे लिख देता हूं? गीगा 10 to the power 9 comes up 10 to the power minus 9. 10 to the power minus 9 is nano. Hertz is 1 by second, comes up, becomes second. So 1 by 5 is 0.2 nanoseconds. 0.2 nanosecond. Okay? हाँ, आगे बढ़ते हैं. Cycle time is this. Okay, fine. Now look at this. This is non-pipeline system. If in the non-pipeline system, one cycle takes 0.2 nanosecond and to execute one instruction, we use sequential execution. Yes, in non-pipeline is sequential execution. Non-pipeline is sequential execution. We need sequential execution, and sequential execution takes 4 cycles per instruction. Means for non-pipeline system, they have given the CPI directly in the question, which is 4. If cycles per instruction is 4, then one instruction execution time is how much? One instruction execution time in this non-pipeline is how much? So in this non-pipeline system only, one instruction execution time is how much? एक इंस्ट्रक्शन को एग्जीक्यूट करने में अगर 4 साइकिल लगती है, 4 साइकिल मींस ईच साइकिल 0.2 नैनोसेकंड, देन टाइम रिक्वायर्ड इज हाउ मच? टाइम रिक्वायर्ड इज 4 साइकिल्स इनटू 0.2, 0.8 नैनोसेकंड्स। बड़ा आसान सा फंडा है। दिस particular one instruction execution time or one operation execution time in the non-pipeline system we denote by Tn. We denote by Tn. We denote it by Tn. Okay, now next thing. Next thing is can you calculate the cycle time for the pipeline system also? ठीक है, pipeline system is having little bit different clock rate. Based on that, in pipeline system, can you calculate in the pipeline system, can you calculate the cycle time? In the pipeline, the cycle time will be equal to 1 divided by 4 gigahertz, which is 0.25 nanoseconds. and this cycle time in pipeline system we denote by TP. Cycle time in the pipeline system we denote by TP. अभी क्वेश्चन देखते हैं क्या दे रखा है. The speed up achieved in the pipeline for 1000 instructions is. So question number 1 we are going to solve. What it says, for 1000 instructions. 1000 instructions means n value given as 1000. For n value given 1000, what is the speed up we can achieve using the pipeline? And the speed up formula we know. Speed up formula we know. What is that? N into Tn divided by k plus n minus 1 into Tp. What is value of k given? How many stages are there in the pipeline? How many stages? 6-stage pipeline given in the question. Look at this, 6-stage pipeline. How many stages are there? 6-stage pipeline. So what is the speed up? Can you calculate? Yes, you can. Yes, you can. Yes, you can. Yes, you can. 1000 into Tn time. Tn time is what? One instruction execution time. Tn time we have calculated 0.8. 0.8 divided by k. K is 6 minus or plus 1000 minus 1 into Tp time 0.25. Solve this. How much you are getting? So it will be 800 divided by, you are getting 3.18. You will be getting 3.18. Are you getting the same answer? Can you confirm if you are getting the same answer or not? If you are getting the same answer or not for the calculation, 3.18 I am getting. Somebody, I guess, written the answer already. That's nice, amazing, pretty amazing. See, look at this, buddy. I told you, right? I told you कि if you are not able to solve cache memory ka question, other questions are coming, you will be able to solve. Look at this, you are able to solve. Okay, fine. So this is question number 1. What is the question number 2 now? What is the question number 2? Question number 2 says that speed up achieved in the pipeline in the ideal conditions. We know that ideal condition speed up is equal to how much? S ideal is how much? S ideal is Tn divided by Tp. Tn, one instruction execution time in non-pipeline divided by one instruction execution time in the non-pipeline system. Non-pipeline divided by pipeline. One instruction in non-pipeline divided by one instruction in pipeline. One instruction in non-pipeline is 0.8. One instruction in pipeline is one cycle time, TP time. Okay, so it is 0.8 divided by 0.25. बताओ कितना आएगा? कितना आएगा? 0.8 डिवाइड बाय 0.25. You will get 3.2. That is the ideal speed up. That is the ideal speed up you can achieve. That is the ideal speed up. Good, great, amazing, amazing, amazing. I want everybody sitting here attempt the questions. Attempting the question is important, buddy. Everybody attempt karo. Now the question is, CPI of the pipeline for 1000 instructions is what? If you are executing 1000 instructions, what is the CPI? CPI means cycles per instruction. Okay, cycle per instruction. So number 3, for, look at this, for 1000 instructions, how many cycles pipeline takes? Pipeline takes k plus n minus 1 cycles. Is that clear? ये होता है, सबको पता है. For, let's say, in general only, for n number of instructions, pipeline take k plus n minus 1 cycles. If that is the case, then for one instruction, how many cycles pipeline takes? K plus n minus 1 divided by n. Is that clear? Is that clear? If these many number of cycles are taken by your pipeline to execute n number of instructions, then for one instruction on an average, how many cycles are required? Divided by n. So, how much it is? Can you calculate that? 6 plus 1000 minus 1 divided by 1000, you will be getting 1.005. And that is what? One instruction. Number of cycles required for one instruction. Number of cycles on an average required for one instruction, and number of cycles per instruction is nothing but CPI. This is the CPI. No? No? Yes? No? बताओ भाई बताओ, क्या ही सही है या नहीं है ये चीज? Yes. Yes, yes, yes. Next one. Next one. What it says? The CPI of the pipeline for ideal condition. Yeah. CPI for ideal condition is 1 without even thinking about the question. Question अगर pipeline में stall नहीं है, if there is no any stall, then pipeline takes 1 cycle per instruction on an average for ideal condition. That is the ideal condition. हर एक instruction के लिए एक cycle. So it's very simple for this one. For ideal condition, CPI ideal is equal to 1. That too without solving the question you can write. If there is no any stall cycle given in the question, then for ideal cases you will be having CPI for the ideal case is 1 in the pipeline. Ideal one, yes, not always, Shweta, it's not always if we will be having the stalls, might possible CPI can increase, but ideal without stall is 1 CPI. Now fifth question. What it says? Fifth question says, in above question, the MIPS count of the pipeline processor is what? If you know what is MIPS, now we are connecting pipeline from the CPU chapter. CPU chapter में आपने MIPS पढ़ा होगा. हाँ सर, याद थोड़ी रहता है. अगर याद नहीं रहेगा तो एग्जाम में क्या लिखोगे? 1 घंटा तो याद करने में लिख दोगे और 2 मार्क मिलेंगे. MIPS is equal to clock rate divided by CPI into 10 to the power 6. This is MIPS. Shweta, for that I need to read a question. So what is the MIPS count? Now I can count the MIPS in 2 cases of pipeline. One for ideal speed up or ideal case, this CPI is 1. One for regular case when I am having CPI 1.005, which is almost 1. So MIPS count, if I will be calculating for ideal case, clock rate is what? Clock rate of pipeline is 4 gigahertz. 4 gigahertz divided by CPI. CPI is 1 into 10 to the power 6. This hertz come down, becomes per second. Giga will become 10 to the power 9. So it is 4 into 10 to the power 9 divided by 1 into 10 to the power 6 MIPS. Now how much it is? How much it is? It becomes 10 to the power 9 to 10 to the power 6,000. So it becomes 4,000 million instructions per second. Got it? Got it? Got it? Got it? Understood? There are so many doubts. Will it be mentioned that there is no stall or not? Yes, Shweta, if you will check out the questions, हर एक क्वेश्चन में ये लिखा रहता है कि स्टॉल रहेगी कि नहीं रहेगी. अगर रहेगी तो कितनी स्टॉल साइकिल्स होगी, क्योंकि उसके बेसिस पे क्वेश्चन सॉल्व होता है. तो हर टाइप के क्वेश्चन में आपको स्टॉल नो स्टॉल लिखा हुआ रहता है. So why CPI goes above 1? Because ideal is 1. Yes, yes, of course above 1 because ideal is 1. एक साइकिल से कम में आप एक इंस्ट्रक्शन कैसे एग्जीक्यूट कर सकते हो? अगर आप इन्फिनिटी मशीन लगा लोगे कि जो जो जीरो टाइम लेगी इंस्ट्रक्शन को एग्जीक्यूट करने में, तो ही आपके पास में इंस्ट्रक्शन का सीपीआई कम आएगा। इंस्ट्रक्शन का जो सीपीआई है वो एक से कम आएगा तभी जब आपके पास एक बहुत ही इंफिनिटी टाइप की मशीन है, अदरवाइज कम से कम एक साइकिल तो लगेगी ही एक इंस्ट्रक्शन को एग्जीक्यूट करने में। ठीक है, और कम से कम इसलिए लिखा है क्योंकि वो आइडियल केस है, वो बेस्ट केस है। पाइप को फिल करने के लिए इनिशियली k-1 साइकिल्स लगती हैं, दैट्स व्हाई सीपीआई गोज फर्दर। इनफैक्ट प्रॉब्लम भी आती है आपके पास पाइपलाइन में, द प्रॉब्लम्स आर द स्टॉल साइकिल्स बिकॉज ऑफ सम हैजार्ड्स, स्टॉल साइकिल्स आती हैं, बिकॉज ऑफ दैट पाइप सीपीआई और भी आगे इंक्रीज होता है। ठीक है, आगे बढ़े क्वेश्चन। ठीक है, चलिए। That is pretty tough question. Okay, now look at this. Consider a hard disk with 36 recording surfaces having 10,000 cylinders and each track contains 64 sectors. Fine. Data in the disk are organized cylinder wise. That is the known fact. We should have the data organized in the cylinder wise, and the addressing format is first of all cylinder, in that surface, and then sector number. A file in the disk is stored starting from address this. First question is, what is the sector number of the first sector of the file in the disk? Okay, so if you have seen my previous lectures, I have given you beautiful explanation, and based on that some kind of formulas to solve this question. Okay, so from here I will calculate how many number of sectors are there on one particular track. Can you tell me how many sectors are there on one particular track? 64. And how many sectors will be there on a cylinder? See, 64 different sectors we have on one track, and such kind of 36 surface tracks are included in one cylinder. So number of sectors per cylinder is 36 into 64. Can you calculate how much it is? How much it is? कितना हो जाएगा बताएं जल्दी। 36 into 64, 2304. So recording surfaces are 36. On each surface will be having 64 sectors. We will be having 2304 number of sectors within one particular cylinder. Okay, now further, what is the further thing? The disk is organized like this way, data organized in cylinder wise, and so on. This is the address of the first particular sector of the file. So if this is the address given 1660, 28, 38, this is the cylinder number, this is the surface number H, and in that this is the sector number. Now, ओहो, एक आंसर भी आ गया है, क्या बात है, अमेजिंग अनुराग, सुपर. लुक एट दिस, वेरी सिंपल. क्वेश्चन नंबर 1 विल बी सॉल्व लाइक दिस वे. कि whatever the cylinder number C given, in that you multiply NC, number of sectors per cylinder, plus whatever the surface number given, in that you multiply number of sectors per track NT, plus sector number S given, this one. Can you do that? It becomes 1660 into NC, which is 2304, plus H, surface number 28 into NT, which is 64, plus S, which is 38. Now I will wait for your answer till you will calculate. You calculate, get me the answer, I will write down here. I will write down here at least 3-4 members answer. I need 3-4 members answer. I am getting, can you please confirm if it is correct or not? I am getting 3826470. देखो क्या आपको भी सेम आंसर मिलता है? इफ यू आर गेटिंग ऑल्सो सेम, ओके, अनुराग का तो आंसर सेम टू सेम है 3826470. आई एम स्टिल वेटिंग फॉर योर आंसर टू. आपका भी क्या दूसरे लोगों का आंसर सेम टू सेम मिलता है कि नहीं मिलता है? जल्दी से बताओ, जल्दी से, क्विकली जस्ट टेल मी सो दैट वी कैन गो फर्दर. Okay. So I am getting this one for first question. This is the sector number of the first sector of the file. This is the sector number. Now question number 2. Question number 2 says what? In above question, if a file is stored on these many sectors in the contiguous manner, then what is the sector number of the last sector? अभी देखिए, starting from this sector, if we are storing total these many sectors, which is the sector number of last sector? लास्ट सेक्टर कौन से नंबर पे रहेगा? अच्छा, एक सिंपल सी बात करता हूं, पहले सुनते हैं. इफ सपोज योर स्टार्टिंग सेक्टर इज 15 से स्टार्ट होके आपको 3 सेक्टर स्टोर करने हैं, 3 सेक्टर्स. स्टार्टिंग फ्रॉम 15 you need to store 3 sectors. On which number you will store the last one? 15, 16 and 17. So you are storing your last sector on 17th sector. 15, 16 or 17. So what you are doing? 15 plus 3 and then minus 1. Minus 1 क्यों किया? Just because we are including the current sector also as a starting. 15th is the starting, then 16, then 17. Last sector is the 17th one. So if I will calculate कि these many sectors are stored starting from this one, so for second question my answer will be last sector number is equal to 3826470 plus these many sectors 55788 minus 1. Can you do it? How much it is? This one plus 55788 minus 1. It becomes 388 2257. Can you confirm if you are also getting the same? Can you please confirm if you are getting the same or not, so that I can go further. Confirm करिए जल्दी से सब लोग. If you are fine with this, जल्दी से confirm करो, जल्दी से confirm करो if you are getting the same or not. Yeah, okay, fine, nice, amazing. Third one says that you need to go in the reverse. Calculate the address format CHS for the last sector of the file. ये same इस type का address I need to get for this particular last sector. Whatever we did this one from CHS like that way, from this reverse I need to go. So if I am going reverse, it's very simple procedure which I already explained in the classroom. How to get cylinder number? You do one thing, you take this 3882257 and divide this by number of sectors per cylinder NC, which is 2304. Whatever the integer value you will be getting, that will be your answer. Okay, one request is there, please explain second two again. Okay, let me finish this one and then I will again explain the second one. Okay, let me finish this one and then I will again explain this one. Look at this, can you do this? Divide this by 23 04, and whatever the integer value you will be getting, that will be your cylinder number, which is 1685. 1685 cylinder number. Now second thing you are going to do is H, which is 3882257 modulus by 2300. Take the modulus so that remaining cylinders only you will be getting, remaining sectors only you will be getting, and then divided by NT. NT is 64. Take the remainder by division of 2304, and after that divide the values by 64. 1685 into 2304, you will be having 17. 17 mod 64, you will be getting 0. You will be getting 0. You will be getting 0 after this division. You will be getting 0 after this. 1685 अभी 2300 से आपने मॉड्यूलस करना है. After modulus, whatever the values remaining, divide by 64, and you will be getting 0 point something, means 0. Check it out. जल्दी से कैलकुलेट करके देखो. 3882257 divide by 2304, whatever you are getting 1685, but take modulus, you will take modulus, become 17. 17 divided by 64, 17 divided by 64 gives you 0. So that will be H. And now last one is S. S is equal to the same thing, 38822 modulus by 2304 and modulus by 64, you will get 17 here. So the address given by this way, CHS, what is C? What is C? 1685, 0, 17. That is the address of the last file. That is the address of the last file I am getting. Last file का जो एड्रेस है या लास्ट सेक्टर का जो एड्रेस है वो इतना आएगा आपका. चेक करके देख लो एक बार. कैलकुलेशंस आर करेक्ट और नॉट. कैन यू प्लीज चेक आउट दैट कैलकुलेशंस आर करेक्ट और नॉट. जल्दी से चेक कर लो कैलकुलेशंस करेक्ट हैं कि नहीं है. कैलकुलेशंस करेक्ट हैं कि नहीं है जल्दी से चेक कर लो, सो दैट वी विल बी एबल टू गो फॉरवर्ड. नाउ समबडी आस्क्ड मी, सर ये सेकंड वाला क्वेश्चन नहीं समझ में आया. देखिए दे रखा है कि एक सेक्टर है, ये वाला सेक्टर नंबर, ये वाले सेक्टर नंबर से स्टार्ट होके आपकी एक फाइल रखी हुई है, और उस फाइल को रखने के लिए आपको लगते हैं इतने नंबर ऑफ सेक्टर्स, 55788. तो सर लास्ट सेक्टर नंबर कौन सा होगा? स्टार्टिंग फ्रॉम दिस नंबर इतने सारे सेक्टर्स स्टोर्ड हैं, तो लास्ट सेक्टर नंबर क्या होगा वही पूछा है सीक्वेंस में. तो अगर एक नंबर से स्टार्ट करो और कुछ नंबर ऑफ सेक्टर्स आपने स्टोर करने हैं, तो लास्ट सेक्टर नंबर क्या आएगा गिन लो, काउंट कर लो. सपोज एक छोटा सा क्वेश्चन मैंने बताया था कि 15th इज द स्टार्टिंग सेक्टर नंबर. सेक्टर नंबर 15 से स्टार्ट हुई है आपकी एक फाइल, और वो सिर्फ 3 सेक्टर पे स्टोर्ड है, 3 सेक्टर पे, तो वो स्टोर होगी 15, देन 16, देन 17. लास्ट सेक्टर नंबर क्या आएगा? 17, विच इज 15 प्लस 3, नो 15 प्लस 3 -1. बस वैसे ही आपको ये वाला कैलकुलेट करना था कि अगर स्टार्टिंग फ्रॉम हियर दीज मेनी सेक्टर्स आर रिक्वायर्ड, तो लास्ट सेक्टर नंबर क्या आएगा? लास्ट सेक्टर नंबर ये -1 कर दिया, इसमें प्लस किया, -1 कर दिया, तो आपको लास्ट सेक्टर नंबर मिल गया और उसका रिवर्स एड्रेस निकाला. अब ये मेथड आपको पढ़ना पड़ेगी डियर. कैसे करना है मेरे डिटेल्ड वीडियो में दिया हुआ है, मैंने बताया है कि कैसे इसको कॉल करते हैं, कैसे इसको सॉल्व करते हैं और कैसे निकालते हैं. व्हाई इट इज सो, ऐसा क्यों होता है, सब कुछ मैंने बताया हुआ है. आप जाके देखिए, आपको समझ में आएगी चीजें वहां पे. चलिए तो आगे बढ़ते हैं. क्वेश्चन नंबर 14, हियर इट इज इन फ्रंट ऑफ यू. Consider a 6-stage pipeline with delays 2, 4, 3, 5, 3 and 4 cycles. This pipeline is upgraded to a new 8-segment pipeline in which each segment delays 2 cycle. ठीक है, तो एक 6-stage cycle pipeline given, 6-stage pipeline is given और उसमें अलग अलग साइकिल्स लगती हैं. कितनी साइकिल्स लग रही हैं स्टेजेस के लिए? 2, 4, 3, 5, 3 एंड 4. तो यहां से क्या आप टीपी टाइम निकाल सकते हो? साइकिल कितनी लगेगी? टीपी टाइम यहां से मैक्सिमम कितना आएगा? मैक्सिमम आएगा इन सबका 5. पता है ना कैसे निकालते हैं टीपी? टीपी विल बी इक्वल टू मैक्सिमम ऑफ दीज सेगमेंट डिलेज which is 2, 4, 3, 5, 3, 4, which is 5. Similarly, 8-stage pipeline is given separately. और ये पाइपलाइन में ईच सेगमेंट इज टेकिंग 2, 2, 2, 2, 2, 2, 2, 2. Right? So from here, can you calculate TP? Yes, maximum of all 2, 2, 2, 2 is 2. How much time is the pipeline saving using new pipeline over old one for 100 इनपुट्स? अगर एक 100 इनपुट्स हैं तो इस न्यू पाइपलाइन से ओल्ड पाइपलाइन के कंपैरिजन में कितना टाइम सेव हो सकता है? चलिए करके देख लेते हैं. तो पहले n इक्वल्स टू 100 के लिए ओल्ड पाइपलाइन कितना टाइम लेती है? कैलकुलेट कर लो. which is k plus n minus 1 into tp. k कितना है? 6 सेगमेंट प्लस n है 100 माइनस 1 इंटू टीपी कितना है? 5. कितना आ जाएगा ये? हाउ मच इट इज? तुम लोग सॉल्व भी करो यार साथ साथ में. 105 इंटू 5 कितना हो जाएगा? 525 साइकिल्स. राइट. नाउ फॉर सेम n इक्वल्स टू 100, न्यू पाइपलाइन टाइम कितना आ जाएगा? न्यू पाइपलाइन टाइम इज इक्वल टू k, विच इज न्यू पाइपलाइन में अब है 8 स्टेजेस प्लस 100 माइनस 2 इंटू 2. ओके, एंड इट विल बी 107 इंटू 2 कितना हो जाएगा? 214. देखिए, इन दिस वन 525 साइकिल्स, इन दिस वन 217 cycles. So can you tell me for the first question answer, how much time you can save using new pipeline over old pipeline if you have 100 inputs? Yes, कितना time save हो जाएगा बताएं? Time saved is equal to, this is taking 525 minus this is taking 214, it is equal to 301 cycles are saved. ओके, 11 आएगा. 311, yes, not 301. 311 cycles. Good, nice, amazing. Is there Unacademy Plus for Computer Science? Yes, Shubhadeep, there is Unacademy Computer Science for Plus members also. And of course, it is very, very effective for your learning. Are you a Plus member? Are you a Plus member? And second question is what? What is the speed up of new pipeline as compared to the old pipeline? अब ये तो कुछ नया आ गया यार. Speed up तो we have already calculated or always calculated based on non-pipeline to pipeline. But here we are comparing two pipelines. Speed up का basic सा simple सा formula होता है slower time divided by faster time. Slower technique time divided by faster technique time. You might have heard this particular word, this particular formula in my classes. Definitely मैंने classes में YouTube पे भी बताया है कि this is the general formula for the speed up. So speed up will be equal to slower technique time divided by faster technique time. In this case, slower is the old pipeline time 525 divided by faster technique time 214. Can you get me the answer for this? Can you get me the answer for this? 525 divided by 214, answer is 2.45, and so on. Around 2.45 you will be having the answer. Okay, got it, got it, got it. So this way you can solve such questions. If you are comparing two pipelines also, you can calculate the speed up by simple formula, which is a conceptual understanding, which I always explain in my classes ki how you will understand it conceptually, ki what is actually the speed up is. Look, okay, let me quickly tell you ki what is the speed up. You have one technique. Assume you have one technique that takes 200 nanoseconds for a problem. 200 nanoseconds for a problem. Now you have made some changes in those techniques, and this time the new technique takes only 50 nanoseconds for the same problem. Previously 200 nanoseconds taken, now 50 nanoseconds only. I can say that my new technique is 4x faster, 4 times faster than the previous technique. Yes, that is the speed up of the new technique. Speed up of 4 means 4 times the new technique is faster than the old technique. Then the old technique 4 times faster it is. Is that clear, cool, understood? If everything is cool about this, clear, understood what is the speed up and how to calculate it, सबको समझ में आया? Okay, so Subhadeep, if you want to join Unacademy Plus, then there is a specific code which you can use. This code is this VD10. This particular code will give you discount if you are going to join Unacademy Plus. Okay, okay, remember this code VDeep10 and you will be eligible for some discounts if you are going for Unacademy Plus subscription. And if you are taking Unacademy Plus subscription, let me know so that I can help you for your further preparation plans. Got it? Okay, चलिए तो आगे बढ़ते हैं. क्वेश्चन नंबर 14 हमने सॉल्व कर लिया है. नेक्स्ट क्वेश्चन इज क्वेश्चन नंबर 15 and that is related to the refresh of the DRAM chips. Okay, a DRAM chip of this has 128 rows of cells with 2k cells in each row. If DRAM takes 20 nanoseconds for one refresh, then total refresh time of the DRAM is how much? Remember, it's a very simple concept which we discuss in the classroom ki one DRAM chip, one chip refresh time is equal to number of rows in the chip of the cells into one refresh time. Okay. Next, this. If number of rows are how many given? 128 into one refresh time. One refresh time given as 20 nanoseconds. Can you calculate how much it is? 128 into 2, 256, 2560 nanosecond. But this is not my answer. This is not my answer. This DRAM is refreshed, or refresh time is asked in the microsecond. Convert this into microsecond. Convert this into microsecond. Microsecond में convert करोगे, divide by 1000 करेंगे, and डिवाइड बाय 1000 करेंगे या ज्यादा करेंगे? डिवाइड बाय 1000 करेंगे या नहीं? यस, ओके, सो डिवाइड बाय 1000 करो, कितना आ जाएगा ये? इट बिकम्स 2.56 माइक्रोसेकेंड्स. ओके, fine, clear, understood, everybody understood this or not, understood or not? So 2560 is the nanosecond. Question is asked in the microsecond. Unit को ध्यान रखना जरूरी है, otherwise you will get correct answer, but if you will not convert the unit, the might possible you will not get the correct result. Fine, clear, cool. Okay, good, Jayesh. So all the members who have joined little late to us, I told in the starting of the lecture that today I have brought only expected questions of COA, so that you will have another session. Yes, another session of expected questions of only डेटा स्ट्रक्चर, सेपरेट, अलग से डेटा स्ट्रक्चर का एक पूरा सेशन करेंगे. आई थॉट आई विल मर्ज टू सेशन, सिंगल सेशन इनटू टू सेशंस इनटू सिंगल वन. आई विल ब्रिंग सम क्वेश्चन, 20-25 क्वेश्चंस फॉर यू फॉर सीओ एंड डीएस, बट आई थॉट नहीं, कम क्वेश्चन में काम नहीं होगा, आप लोग खुश नहीं हो पाओगे. सो फॉर योर हैप्पीनेस, फॉर योर betterment, I have brought only questions of COA first, and then next time we will solve the questions of data structures. Okay, let's go for another question. Still we have 7-8 questions left. Okay, so don't go anywhere. Let's solve the question. Another one. Consider a system with a word addressable main memory. Okay, word addressable main memory. Okay, word addressable main memory. Fine, means address of the main memory will be for a word. Maximum capacity 16 gigabytes. Got it. So further, I'll check it out. Okay, the system uses a direct mapped cache with 8 megabytes. So cache size is given as 8 megabytes. Cache size given as 8 megabytes and main memory size given as 16 gigabytes. The block size of 128 bytes. The block size is of 128 bytes. Fine. The system has 32-bit architecture. What does it mean? What does it mean? System has 32-bit architecture means the word size is 32 bits. The word size is 32 bits. Word is equal to 32 bits means how many bytes? 32 bit में कितना बाइट होता है? 1 byte is equal to 8 bits. So 32 bits means 4 bytes. The size of main memory address, tag and index fields are. First of all, you need to understand this कि if you have the main memory word addressable, which means CPU generates address for each and every word, not for the byte. So everything you will have in word in this particular case. You should have everything in word. Convert if not given. So everything you need to convert into the words. So if cache memory size is 8 megabytes, in 8 megabytes, how many words of 4444 bytes? 8 MB divided by 4 byte, which is nothing but 2 mega words. This is the cache memory ka size. Two mega words are there in the cache memory. Similarly, further, main memory size is 16 GB, 16 gigabytes divided by 4 bytes. You will be having 4 giga words in the main memory. Block size 128 bytes, 128 byte divided by 4 bytes. You will be having 32 word ka block size. Everything you need to convert into word. Done? Yes. Now, based on main memory ka size, this 4G words, which is 2 power 32, can you get me the address size from here? Yes. Main memory ka address will be of 32 bits. Main memory generates address of 32 bits. 32 bits. Okay, so we know कि in the direct mapped cache given in the question, it is given in the question कि cache is direct mapped. The direct mapped cache, the address of main memory is divided into three parts. So address of main memory, which is of 32 bits, divided into three parts. What are the three parts? Tag, then cache memory ka block number, which is nothing but index, and then word offset this time. Why word offset, sir? Why word offset? We keep byte offset, na sir? Sir, memory is word addressable, so address this 32-bit address for word. That's why word offset. That's why word offset. If main memory is word addressable, everything in word. Main memory address is also word offset. If memory is byte addressable, CPU generates address for a byte, everything in byte. Now 32 is the main memory ka address size. So this particular first question is already solved, 32 bits. Now how many tags and index fields? First of all, let's calculate number of blocks in the cache memory. Number of blocks in the cache memory will be equal to cache memory ka size, which is 2m words, 2 mega words, divided by block ka size, which is 32 words. 2 mega is 2 power 21 divided by 2 power 5. Answer is 2 power 16. So if number of blocks are 2 power 16, 16 bits will be required for cache memory ka block numbering. For cache memory ka block numbering, 16 bits is required. And word offset ke liye kitna lagega? If 32 words are there, based on that, word offset will be of 5 bits. 5 bits. Okay, so 5 bits will be required for word offset. 32 में से 16 plus 5, how many bits gone? 21. So how many bits are for tag? 11 bits. 11 bits. So what is the question? Main memory address 32, tag 11 bits, and index field. Index field means the middle field. These 16 bits are there. 16 bits are there in the index field. So remember, what is the learning from this question? Learning is, if everything is given in bytes and main memory is byte addressable, keep everything in bytes. If memory is word addressable, keep everything in word, and then solve the regular question which you solve always. Right? Got it? Understood? Should we go for the next one? आगे बढ़े? बताओ जल्दी से, आगे बढ़े कि नहीं बढ़े? आप लोग थोड़े कूल हो रहे हो. आप कूल मतलब हिंदी में बोले तो ठंडे पड़ गए. अभी आपकी एक्साइटमेंट कम हो गई है. नहीं रे बाबा नहीं. चलिए अगला क्वेश्चन डीएमए से ये रहा आपके सामने. अ डिवाइस is constantly transferring the data with 20 kilobyte per second speed to memory using DMA. Fine. Assume that transmission time to memory from IO once data of 1 byte is ready is 5 microsecond. So 1 byte data is ready, then transmission is 5 microsecond. Fine. Further assume that a file of 5 kilobyte needs to be transferred to memory. Then how much percentage of CPU is blocked due to DMA in the burst mode and due to DMA, okay, not die to, it should be due to, in the cycle stealing mode. First of all, let's calculate how much time this device takes to prepare 1 byte ka data based on this speed. Let's calculate based on this speed how much time the device takes to prepare the data of the 20 kilobytes. 20 kilobytes. Okay, fine. Now, based on this, I can say 20 kilobytes ka data can be prepared in how much time? Per second? 1 second? If 20 kilobyte can be prepared in 1 second, then 1 byte can be prepared in how much time? 1 byte can be prepared in how much time? 1 second divided by 20 kilo. Right? Right. Into 1 byte. Now, how to calculate this? First of all, this k goes up, becomes 10 to the power minus 3. Okay, what I am doing is I am writing it like this way. I am multiplying it by 1000 and dividing also it by 1000. So it becomes 20 into now 10 to the power 6 seconds. मल्टीप्लाइंग बाय 1000 डिवाइड बाय 1000 से डिवाइड करके इसको ए में मर्ज करा 10 टू द पावर 6. दिस 10 टू द पावर 6 goes up and becomes micro. 1000 divided by 20 becomes what? 1000 divided by 20 becomes what? Becomes 5 or 50? जल्दी से बताओ, 5 or 50? 50 microseconds. This becomes 50 microseconds. So 50 microseconds are required to prepare the data. प्रिपेयर करने में डेटा को 50 माइक्रोसेकेंड लगेगा और साथ ही साथ 5 किलोबाइट को ट्रांसमिट करने के लिए 5 माइक्रोसेकेंड लगेगा. ओके, दिस क्वेश्चन डायरेक्टली यू कैन सॉल्व इवन विदाउट कैलकुलेटिंग द फर्दर 5 किलोबाइट का ट्रांसमिशन टाइम. फर्दर यू कैन डायरेक्टली कैलकुलेट इट without even considering this, just because data size is byte only. Okay, now listen how can you solve? DMA में burst mode, अगर burst mode है तो first question based on burst mode, what is the preparation time of one byte? 15 microsecond. What is the transmission time? 5 microseconds. So you can have it like that way. Percentage of time CPU is blocked due to DMA in burst mode is equal to how much is transmission time? 5 divided by 50 plus 5 into 100%. Can you calculate how much it is? Can you calculate how much it is? It is 5 divided by 55 into 100, 9.09. 9.09. And the second question, percentage of time CPU is blocked in cycle stealing mode is equal to 5 divided by 50. Directly we need to do 5 divided by 50 into 100%. ऐसा क्यों किया? क्योंकि cycle stealing mode में we can say कि in the cycle stealing mode we can say that we will be having the parallel preparation and parallel transmission. That's why, and this becomes 10%. This becomes 10%. Okay, got it. Can you acknowledge that? Is it understood or not? Come on. Got it or not? Can you verify if it is clear or not, so that we can go for the next question? Next question is about fully associative cache. Fully associative cache maintains 24 kilobyte का tag directory. Okay, and if cache memory contains 2 power 13 blocks, then how many number of blocks are there in main memory? Okay, so we know कि tag directory का size is equal to number of blocks in cache into tag का size. Extra bits are not given in the question, so this is my formula. Simple. Now tag directory size is given, yes, 24 kilobytes is equal to number of blocks given. Number of blocks given in the cache. Number of blocks given in the cache is how much? Number of blocks given in the cache is equal to 2 power 13 into tag ka size. So what is the tag size you can have here? Tag size is 24 kilobyte divided by 2 power 13. Let's make it in 20 bits. So it is 24 kilo into 8 bits divided by 2 power 13. You can make k and 8 combined 2 power 13 से ये cancel हो जाएगा. It becomes 24 bits. 24 bits is your tag size, and if you have taken my classes, then in my classes I have explained this concept really well कि in the fully associative mapping the tag size is nothing but cache memory, main memory का block number. Main memory ka block number. So how many number of blocks are there in the main memory? In the main memory, number of blocks in main memory is equal to 2 power 24 blocks. If numbering is of 24 bits, then 2 power 24 blocks you can have in the main memory. Very simple, very simple, very simple. Next question number 19. Question number 19 is again amazing again. The system is, there is a system in which 16-bit instruction and 6-bit addresses are there. Okay, it's supposed 2 address and 1 address instruction. Okay, as soon as I read this, again I am telling you, आपको सबसे पहले क्या करना है, फॉर्मेट बना लेना है. फॉर्मेट बना लो जल्दी से. 2 एड्रेस और 1 एड्रेस का बना लिया सर. अभी क्या करें आगे? अभी इसको सॉल्व करेंगे आगे. चलिए सॉल्व करते हैं. कैसे करेंगे? 16-bit instruction. Fine. So this is opcode and 2 addresses, address 1 and address 2. And in 1 address instruction you will be having only opcode and an address, 1 address only. ठीक है. अभी बात करते हैं 16-bit instruction, 6-bit addresses. So 6-bit addresses, 16-bit instruction, 6-bit addresses. How many bits for opcode here? 4 bits. How many bits of opcode here? 10 bits. Suppose there are maximum possible 1 address instructions are A and minimum possible 1 address instructions are B, then maximum value of A minus B is. Now what I need to do is I need to calculate maximum number of 1 address instructions. How can I get maximum number of 1 address instructions? I will take minimum number of opcodes for 2 address, so that maximum 1 address instructions I can get. How to solve? Let's see. So using these 4-bit opcode, how many maximum opcode you can have is 2 power 4, which is 16. Among those, you do one thing, you use only one. Minimum possible you use only one, so that maximum combination I can keep for 1 address instruction. So how many are unused? 15. These 15 I am going to use for 1 address instruction. How? For 1 address instruction, these 10 bits I'll have to divide into 2 parts. What are the 2 parts? First 4-bit and remaining 6 bits. Now using these 4 bits, I am having unused 15 into 2 power 6, which is कितना होगा? जल्दी से कैलकुलेट करो. These are the maximum 1 address instructions possible. These are maximum 1 address instructions possible. So it will be 15 into 64, 960 1 address instructions possible. These are the maximum. Means A value I got 960. I have got A value 960. अगर A value 960 है, minimum कितना आएगा? Minimum B value I will have to take 1. Why? Just because for any type instruction, if a computer is supporting, then I need to take minimum number of such instruction is equal to 1. I need to take minimum number of such instruction is equal to 1. So in that particular case, 1 is the minimum. What is the value of A minus B? 960 minus 1, answer is 959. That is your answer. That is your answer. So 959 will be the maximum value of A minus B. क्लियर, कूल, अंडरस्टूड. आगे बढ़े. और हमारे पास 3 क्वेश्चन हैं. देखते हैं कितने क्वेश्चन हैं. आई डोंट रिमेंबर द काउंट, बट वी आर हैविंग at least 2 more questions to be solved. Let's see what we are going to solve with those. Consider a pipeline has 6 stages and the branch outcome of the branch instruction is available after 4th stage. Means after 4th stage only next instruction after the branch instruction is fetched. In my classes I told you कि if after 4th stage the branch outcome is available, means because of the branch stall will be 4 minus 1. आंख बंद करके आप 4 minus 1 लगाओ. 3 stall cycles will be there. If after 4th stage branch outcome available, then 3 will be the stall cycles because of the branch. Consider the program execution in which 20% instructions are branch. Okay, so 20% instructions are branch instruction. Fine. If the pipeline stage is taking delays 2 nanosecond, 4, 5, 3, 4 and 2, then from here you can calculate TP. TP time will be equal to maximum of 2 plus 4 plus 5 plus 3 plus 4. What is it? Okay, 2 और बच गया. What is the maximum? 5 nanosecond. See, in the question there is no any register given. That's why we are not adding any register. So it's 5 nanosecond. Average instruction execution time I'll have to calculate here. In such kind of question, first of all, we need to calculate CPI average. We need to calculate average CPI. And how do we calculate average CPI? It's very simple thing. One cycle is needed for each instruction on an average, plus but we have 20% branch instruction, so 20% time we will require 3 extra cycles. So this will be the CPI average, which is 1.6. 1.6 will be the CPI average. If CPI average is this one, means number of cycles per instruction on an average 1.6. अगर 1.6 number of cycles per instruction on an average hai, then what will be the average instruction execution time? So it will be number of cycles into cycle time. So my answer for the question is average instruction execution time is equal to 1.6 into 5, 8 nanosecond. 8 nanosecond will be the average instruction execution time. Cool, clear, understood? चलिए, okay, तो ये रहा आपका सॉल्यूशन की जगह तो मैंने वहीं कर दिया. Okay, this is your last question of the day. This is your last question of the day. A CPU runs on 500 megahertz clock rate and is executing a program which consists 1000 instructions. Okay, so if it is running on 500 megahertz clock rate, can we calculate CPU का cycle time? You calculate CPU का cycle time. कैसे करेंगे? 1 divided by this. It becomes 0.02 और ज्यादा, 02 और 002, 0.002 microseconds. 0.002 microseconds. कैसे किया? Mega will go up, becomes micro, hertz will go up, becomes second. 1 divided by 500 is 0.002. That is the cycle time. It is executing a program which is consisting 1000 instructions, and if the measured CPI, average CPI of the program is 6, So CPI average given already. CPI average is equal to 6. And cycle time is this. One instruction execution time will be CPI average into this. But question is asked what? Total time required to run the entire program. Entire program which is consisting 1000 instruction is, so total execution time will be how much? Total execution time will be equal to number of instructions 1000 into CPI which is 6 into cycle time which is 0.002 microsecond. कितना हो जाएगा जल्दी से कैलकुलेट करके बताओ. It becomes 12 microseconds. Great, amazing. एक आंसर तो आ भी गया. अरे amazing, amazing, amazing. 12 microsecond will be the correct answer. Yes. Good, good, good. Superb, 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 superb. चलिए, तो we have solved so many questions today of different topics, and those questions started from here. We have started from instruction chapter, and then almost all the chapters we have solved, and all type of expected questions we have solved today. So my dear friends, it's very simple thing that if you guys are able to solve maximum questions today, well and good. If not, then please give more time for your preparation. थोड़ा और टाइम दो, अंडरस्टैंड करो हाउ टू सॉल्व द क्वेश्चंस, एंड यू विल डेफिनेटली लर्न हाउ टू सॉल्व सच क्वेश्चंस. आपको बहुत मजा आएगा, बहुत बहुत ज्यादा मजा आएगा. Okay, if you guys are learning from our Gate Express batch, in the Gate Express batch COA will be finished in few days. These all courses will be completed in within few days, and new 3 courses will come definitely on the place of these courses soon. So stay tuned with this Gate Express batch, and if you are learning data structure from me, 10 a.m. my classes are going on data structures. Tomorrow we will be having another 10 a.m. class on data structure, and tomorrow we are going to talk about traversals. So I am going to give you lots of questions only on traversal and traversal. Okay, fine. So this is very important session. This is gonna be a very important session, so don't miss that particular session, just because based on traversal maximum number of questions come from the tree chapter, somehow related to any kind of traversal, any kind of tree. So don't miss that particular topic at all. Okay, fine, cool, clear. This is my team working in and out a lot for you guys, so give some kind of payback to these people in terms of sharing the lectures with all of your friends, sharing the words about these fellas, including of course मेरे बारे में बताना यार, of course about me also to all of your friends, so that they also know कि this particular team of the Unacademy working really well for them. If you gonna take the PDF of the classes which I am taking here, all these PDF and the announcement of the classes we drop on this particular official channel of Unacademy on Telegram, go there and join this. If you people are wanted, if you want me to be connected with you, you want to connect with us, then these are the Facebook channels. You can connect with us and you can enjoy that connection, just because so many announcements, so many questions, so many new things you can get over there on Facebook channel. One more thing you need to do is you need to let all of your friends know exactly that what we are providing them. You can see this is Creatrix channel for electrical members. If you have friends in electrical, let them know electrical ECIN के लिए ये channel है, और वो उन्हें वहाँ redirect करें आप, so that they also can learn a lot about the quality education from our quality education. This is for mechanical, सिविल, तेलुगु लैंग्वेज, एसएससी जेई का चैनल भी है हमारे पास. ये देखो यहाँ पे जनरल स्टडी का चैनल है. दिस इज द चैनल फॉर कंप्यूटर साइंस. इफ यू हैवंट सब्सक्राइब द चैनल, प्लीज सब्सक्राइब द चैनल, share the links of all these lectures एंड दिस लाइक कर दिया करो हर बार जब भी आप क्लास में आते हैं तब. एवरी सेशन विच यू आर अटेंडिंग फॉर अ फ्यू मिनट्स और फॉर एंटायर सेशन, लाइक द सेशंस प्लीज ऑलवेज, एंड ऑलवेज टर्न ऑन दिस पर्टिकुलर घंटी. ये घंटी टर्न ऑन कर लो, ये नोटिफिकेशन टर्न ऑन कर लो, सो दैट वेन एवर आई विल बी कमिंग फॉर द क्लासेस यू विल बी गेटिंग द नोटिफिकेशन. ओके, thank you so much for joining here live. If you are watching this lecture in offline mode too, thank you so much. If you want to take Unacademy Plus subscription, use the code VDEEP10. याद रखें, ये VDEEP10 कोड यूज करना है आपको आपके सब्सक्रिप्शन के लिए, and you will get discount of 10% plus lots of other benefits. Thank you so much for joining. Yes, PDF I'll be dropping on this particular channel, this one, Unacademy Gate CS. Yesterday's and today's all the PDFs I'm going to drop just now within 2 minutes. Okay, thank you so much for joining. Thank you so much. Happy learning. Have a nice remaining day. 12 p.m. I am having another session on gate PYQs of stack. Second part, yesterday we have solved some questions. Today also I am going to solve some questions. 12 p.m. See you soon. Till then, bye bye.